So this is going to be an examination of how to fix the issue that you can see in this scene. This is a procedurally generated terrain, and you can see these gross lines up the middle. And what is causing that is the normal calculations for the tiles. So these are happening on tile boundaries. So if we look at buffer visualization and world normals, we can see these lines exist in the normal map. And what we need to do is correct the boundaries between the tiles. So when this tile is generated, it doesn't know anything about this tile over here, and thus it doesn't have this correct edge information, and the edges on these normals are incorrect, so you're going to see these boundaries. So we need to expand the tile when we generate it and generate triangles around the edge to correct that normal calculation, and that's what we're going to do. So if you haven't built a procedurally generated landscape like this, then this this tutorial isn't going to be useful to you. But if you have followed along with Fettis GameDev's development, then you'll have this problem, and we can correct that, and this will be an explanation of how to do that. So the first change we want to make is inside of our landscape tile, or the chunk, and it's down in this part here. We are calculating our normals. Right here we're calculate tangent for meshes, and that gives us our normals. And what we want to do is we want to add the additional squares around the tile in this create vertices and create triangles. So we're going to go into create vertices first, and we're going to change this to loop from -1 in both of these. So we're going one previous square outside of our X and Y direction, and then we're going to go, instead of going to size, we'll go to size +1. And that'll go into here and here. So that'll give us an extra square on the outside of our current tile, which we're going to have to remove later. So that gives us the extra vertices. The next change needs to happen in create triangles. And I think the easiest, least invasive way to fix this is to create a new local variable we'll call extended size. And then we're going to set extended size here to be our tile size +2. So now wherever we used size before, we'll use extended size instead. So we'll just replace all these guys here. You might notice this looks a little different. I just have it laid out differently than Fettis did, but it's the same. I laid this out differently because I actually would like to really rewrite this mess, but I haven't done that yet, so it is the same as it is in the original. So now we should be generating 2 more squares around the edge of our tile. And the result of that, if we generate our landscape, is that on our edges, you can see this blinking here because we have overlap with these extra tiles, or these extra squares extending off of our every tile. So it's overlap between each edge. I know we need to get rid of that. So now back in our generate function, generate our landscape or land or tile or whatever chunk it's called. So we've created our extra vertices and our extra triangles. We want to use those here where we calculate the tangents, but then we don't want them when we create this mesh section. So what we're going to do is take those extra triangles and vertices back out here after this normals calculation and tangents calculation. We actually don't need to set these variables here. I'm going to get rid of those. This is the only place they're used. Oops. That variable's needed. Normals, tangents, those just come right in here. So they can just do that. We're going to take this, get this out of the way, and then we'll do this. And we're going to turn this into a new function. And then we can run this right in directly to our create mesh section. And we're going to create this function, remove extra squares. And then let's go into that. So inside this function, we can break all the connections here until we have this. So we're gonna calculate our tangents as we did before, and then we want to remove the unneeded data from around the edge. So we're gonna loop back through our size just like we did here in create vertices. So we can actually copy this over to our remove extra squares function, and we'll loop back from our index of -1 up to our size +1. So let's make this a little more clear. Let's change these vertices to in vertices. We'll have in triangles and in UVs. And then we want to promote normals to a local variable we'll call extended normals. And same with tangents. So we'll set both of those. Then in our loop here, we can call this, we'll call it local x. And we'll call this local y. And then we want to test if we have a valid index of these x and y's. So we're going from -1 up to our size +1, and we want to get rid of the +1s and we want to get rid of the -1s. So we want local x is greater than -1 and it's less than or equal to our size. Then it's valid. And the same thing for y. So we'll copy this, make another one. We'll move these guys over here. And instead of local x, we'll use local y. And then we want all of these to be true for a valid index. So we'll do an and we'll add those pins. And then we'll run that out to a branch. And then if that's true, we have a valid index. So now we want to take a subset of our vertices, triangles, normals, UVs, and tangents, and output those here, right? So we don't need these variables here. What we want here is the subset. Create a new variable here. We're going to call just out vertices, out triangles, out normals, out UVs, and out tangents. Alright, so we'll set each of these with our subset of our original variables. Except for the triangles, we're going to do the triangles a little differently because they're complicated because of the 3 points. But we can set each of these using this up here. So what we need is our original vertices, which is in vertices, and we're going to get, and we just get a reference, and we need an index. So we can just create a local variable index. It's going to start out at 0. We're going to increment it at the end of this. And then we'll add this to our new out variable, out vertices. So we're only adding that if this is true, and when it's false, we'll just end up skipping over the index. So we need to increment this index at the end here, so we'll get our index and we'll increment it, and we're going to do that after all of these and also when it's false. So here we're going to just do the same thing for normals, UVs, and tangents. Alright, so we have all those in here, and then we're just going to take this, run this increment down to the end. This is our same index, so we can move that over there and get rid of this. And then this guy goes here. So we're incrementing both on true and false. And we can see that that's the same index on all of these. So then for triangles, it's a little more complicated, and rather than figure out what to remove, the better way I think to do this is going to be to recalculate our triangles. So we're going to do that with our calculate or create triangles function, and we're going to take this, and instead of using our extended size, so what we're going to do here is we'll add a branch, and we'll add a variable here, input variable that we'll call extended. And if we want the extended, then we'll use this branch, and we'll add to this extended size, and maybe we'll rename extended size to local size. Because in our false branch, we're just going to set that to be size as we had in the first place. And now when we call that, originally here we want extended size. But when we call this again from remove extra, which we're going to do here at the end of completed, we don't want the extended, so that'll be false. So I think it's safe to clear the array of triangles here. And then we'll recreate it with the extended off, and that should give us our new triangles, and then we don't even need to output them here because they'll be set. We got rid of that triangles variable, and we'll just use our triangles that have been reset into create mesh, and that should do it. I had a bit of a bug there. This is correct with the create triangles, but it needs to come off this outer loop here, not this inner loop here. I had hooked it up here originally. It should be here because otherwise we end way too early. So we want to come off the outer loop and create our triangles and then output this to regenerate. And then if we run this, we see our landscape now has none of those pesky lines. Let's double check. I do see a little line here. So let's go back into the normals. That line is not from the normals, it is from the textures. Look at that beautiful lineless scene. Let's extend the size of that. Looking pretty good. So we can improve on this again by improving our textures. So this kind of here we're seeing some banding. This is from how we're doing our textures, so we need to change the textures, but it's pretty easy to do just with macro variation built into the auto texture. So I'm going to do that next. This is how a macro variation material works. I don't really want to do a whole video on recreating this. It's been done by other people, but I am going to take this method and apply it to the auto material. Rather than do the make material this way, what we want to do is with this base color here, we want to put in that macro variation. So we're going to take all this stuff and put it into the make material. So what this is doing is it's calculating distances using the texture coordinates, and it's applying different weights to them and applying them to different samples. So these are standard samples up here, and then it's multiplying those together, applying a noise contrast, and it's just lerping between that. And this is basically creating variation on top of your normal texture, which is in here. It's also in here. That texture is repeated several times in this, and then each of these just applies different weights, moving that texture around to create random variation that fits the look of that material. So we're going to take all this stuff, we're going to apply it into make material in place of this. So I created this landscape material with the macro variation based on a video from GameDev Academy, which I'll just link in the description because he goes over this in detail. And so once you create this, what I've done is I've copied all these nodes here, except for these ones. We don't need the roughness and the normal, and we've gone over to our macro material, and I've pasted those in here in place of our base color. I've added this metallic of 0, which you don't necessarily need, but that prevents any shininess that might happen depending on your material. Then I've taken the texture sample nodes here, replaced these base color nodes with the texture sample nodes. So these are all now texture sample nodes. That feeds in from the diffuse parameter into all these texture sample nodes. And these have to be hooked up the same as they were before. This is hooked up to RGB, this one's hooked up to green. Same here. This is hooked up to RGB, this is green. Those all go through all this stuff. And that goes in and replaces the base color that was in here before. The normal and the ambient occlusion and the roughness are all the same as they were before here, except I'm feeding in a texture coordinate here instead of the world position. And that becomes the new make material, which then goes in our auto material. Make material with macro variation in place of these two nodes. And that's all there is to that. Now if we generate a final time, we can see the texture looks much better with the macro variation. We don't see as much banding. This probably can be improved slightly further, but the result looks really quite realistic. If you did find this helpful, please like and subscribe. I did just start this channel recently, and I will be adding a lot more content. I plan on using this procedural landscape in the future, adding procedural content generation and water to this landscape, and expanding on this idea. And so subscribe so you can catch that later, and welcome to the channel. Thank you.